Okay. This is the Chapter 6 test review. This is video 3. Looking at complex numbers. Standard form, complex number in standard form is written as something like z equals a plus bi, right? Complex numbers, we're familiar with that. You can write complex number in trig form, which would be z would equal r, and then cosine theta plus I sine theta. Now, we need to find these various things. So we need to find r. R is going to be the square root of a squared plus b squared. Okay. And then theta, to find theta, we would take the tangent theta, tangent of the angle, equals b over a. And again, the b, this a and b, this b over a, this is all based off of that standard form. So if we're not given r and we're not given theta, so if we're not given these angles, we're not giving them, then we have to be given a and b, right? We have to have a and b. So, and then if we have a and b, but then we could use that to find each of these. So that angle is going to be, well, the reference angle is going to be arctangent of b over a. Now, why would I say reference angle, not the angle? Well, so I can give you an angle, but you have to look at where it is. So if it's written as a, so if it's, if it's a plus bi, they're both positive, then you're in Q1. You're all right. Okay. If it's, negative a plus bi, then you're going to be in Q2. Excuse me. Negative a minus bi, you're in Q3. And then a minus bi, you're in Q4. So you have to look at where you are, because if you're in Q1, then let's just write down here. Q1, then the reference angle theta equals theta. Q2 is 180 degrees minus the reference angle. The reference angle equals theta. Q3, it's 180 degrees plus the reference angle, gives you your angle. If it's in Q4, Q4, then it's 360 degrees minus whatever your reference angle is. So that that is our reference angle. And then the angles that you would put in here, right, are going to be dependent on all of these, on what that actual angle is. Okay, product formula. In other words, if you have one complex number z sub 1 times another complex number z sub 2, first of all, it has to be, product formula has to be in trig form. Okay, that's true for the quotient formula, for the product formula, and also for de Moivre's theorem, or the power property, aka power property. Okay, so z sub 1 times z sub 2, we're going to do r sub 1 times r sub 2. So we multiply two r's together. And then we're going to do cosine of one angle plus the other angle plus I sine of a plus b. Okay, because then you have like z sub 1, right, is going to be r sub 1, and it's going to be cosine of a plus I sine of a, right? And then z sub 2 equals r sub 2, and it's going to be cosine b plus I sine b, right? So those are the a's and the b's there. Quotient formula, z sub 1 over z sub 2 is going to be r sub 1 divided by r sub 2. And it's going to be cosine of a minus b plus I sine of a minus b. Okay, so that's the quotient formula. Power property, you should have all this written down already. Or De Moivre's theorem. Okay. So this is when we have z to the nth power. Then we're going to go r to the nth power. And then we're going to go cosine of n times whatever our theta is. So we're going to multiply n times that angle. And then plus I sine of n theta. So we multiply n times the angle, and then we take the cosine of it. N times the angle, take the cosine of it, okay? And then you can multiply if you have to, if it wants it in standard form, then you would get those values, and then you'd multiply r sub n into there, and you distribute into here. Okay. All right, this first one, we're going to look at this actually twice. I'm going to do kind of quickly the first time, and then we'll kind of go through the long math of it. But this is one where you can, or you could hopefully identify, well, let's see, if I just take out a 15, that leaves me with 1/2, and it leaves me with root 3 over 2i. Okay, so now we have our r. All right, so we don't have to find it, and we also kind of know what angle we have, because this is the x and the y of an angle. Now, this is, just real quick, this is positive and this is negative. That means we are in Q4, right? Positive, negative. These values, this 15/2, or these values are down here. Now we have the x is 1/2. And this is negative. Well, that would be right here. That would be our angle 1/3, 2/3, 3/3, 4/3, 5/3. 5 pi over 3. Or, well, we'll leave it like that for right now. 5 pi over 3. So then you would have 15 times the cosine. Let's see, write the trigonometric form of oh yeah, because it wants a trig form. So this would be cosine of 5 pi over 3 plus I sine of, and it's always plus. This, just because it's minus, that just tells us that it's 5 pi over 3. Okay, or you could do z equals 15. Maybe we want it in degrees instead of radians. Well, that would be 300 degrees, right? So this would be cosine 300 degrees plus I sine of 300 degrees. Okay, either one of these are correct. That's okay. That's in radians, and this is in. It didn't tell us it had to be in degrees or radians. So either one, both okay. But the main thing is that they are in trig form of the complex numbers. Okay. So I said we're going to do two ways. That's if you can recognize the fact that you could factor out 15. If you recognize that, then you would do that. Now, let's say like either we didn't recognize that we could factor out the 15, or maybe we just can't factor something out. We still know this is in Q4. Okay, but here we would go, okay, our r would be the square root of 15 over 2 squared plus negative 15 root 3 over 2 squared. And this, if you do the math on it, actually equals 15. So like if we didn't recognize that we could distribute out the 15, we could do the math and find out that that's 15. And then we come in here and we say, okay, well, theta equals arctangent, right, of negative 15 root 3 over two. Oops. Yeah, so it's b over, right, b over a, and this would be 15 over 2. Right, because it would be this value over that value. And when you put this in your calculator, you get 60 degrees. By the way, this is the absolute value of it. So you get 60 degrees, and then since we know it's in the fourth quadrant, we go 360 minus 60 degrees equals 300 degrees. And therefore, we have z equals our r, 15, times cosine of 300 degrees plus I, sine of 300 degrees. Okay. So a couple of different ways of doing it. If you can recognize what you could distribute out, that's great. If you can't, you could still find 15 using the formula. You could still find the angle using the formula. Okay. All right, let's go a little faster through this. All right, so we want to find r, negative 5 squared plus 2 squared, square root of 29. Now I want to find theta prime equals arctangent of 2 over negative 5, which is approximately 21.80 degrees. So since this is, let's see, this is negative and positive, so we're in Q2. So theta equals 180 degrees minus my reference angle. So this equals 180 degrees minus 21.80 degrees. Where's my... So we have z equals r, square root of 29, cosine of 158.2 degrees plus I, sine of 158.2 degrees. And there's your answer. Okay. So we're going to go r times r, and then it's going to be cosine a plus b plus I, sine of a plus b. All right, so 3/4, that's, oh no, oops, times, so 3 times 4, pi over 3 plus pi over 7. Okay, so this is 12 cosine of 10 pi over 21 plus I, sine of 10 pi over 21. Write the trig form. Okay, well that's it. Trig form. All it wanted was the trig form, right? Oh no. Perform the indicated operations. Oh, standard form. Shoot. So what do I have to do? I have to use my calculator. I've got to multiply 12 times whatever this is. So I have to use my calculator, figure out what 10 pi over 21, what the cosine of that is, then multiply it by 12. What is this? Multiplied by 12. So that gets a little tricky, but I will tell you the answer. 0.897 plus 11.966i. Okay. So we have r over r, and then we're going to have cosine of a minus b plus I sine of a minus b. So 3/5. And this is going to be cosine of 2 pi over 3 minus pi over 9 plus I sine of 2 pi over 3 minus pi over 9. Let's see, 3 times 2, 6, so this would be 5 pi over 9 plus I and 5 pi over 9. Well, it's in standard form, so we have to get out our calculator. Why am I putting equals right here? I don't know. I don't know what I was doing there. So just plug it in our calculator, and we get negative 0.104 plus 0.591i. All right. So you just use your calculator again. You'll find cosine of that, and you'll multiply it by here. You'll find sine of that, and you multiply it by that. Okay. Oh, let's see if we get through here quick. Okay, so we're going to use the power property. We're going to take 2 to the 5th power, and then we're going to go cosine of 5 times 7 pi over 5 plus I sine of 5 times 7 pi over 5. Okay, so this is 32 cosine of 7 pi plus I sine of 7 pi. 32. This is negative 1, right? 7 pi. 1, 2, 3, 4, 5, 6. So it's the same as pi. What am I doing here? I don't know what I'm doing right there. Daydreaming. Oh, no, that's right. Cosine of cosine of 7 pi is -1. And then this is 0i. It's just 0. Right? So we're just going to multiply -32. That's it. Okay, so r equals 2, and then theta prime equals arctangent of -√3/1. Oh, that looks... Let's see. We have negative, positive, so we're Q2. This is Q2. So we have... $90 and $30, $120. Yeah. So our angle, well, yeah, knowing where we are. Okay, so theta equals 120 degrees. So we're going to go 2 to the 7th power cosine of 7 times 120 degrees plus I sine of 7 times 120 degrees. So 128 cosine of 90 degrees. This is 1/2.